For today's lesson, we're going to solve rational equations. Previously, we've already added, subtracted, and graphed the rational equations. Now we're going to go in and solve them. Now, for little problems like this, it's really simple. You just cross multiply, and then we're going to solve for x and find excluded values. When cross multiplying, you bring the bottom expression from the opposite side of the equal sign up to meet the top side. So what that's going to do is the x minus 1 is going to come up and multiply times the x plus 4. And then the 2x minus 2 is going to come up and multiply times the x plus 3. Now at this point I expect that you can multiply these in your head, but if you can't, remember, set them up top and bottom. Now, I see that I have a quadratic. Since I have a quadratic, I need to set them equal to 0, meaning I need to get all of the pieces to one side. So at this point, I'm going to take the x squared, the positive 3x, and the negative 4, and I'm going to move them to the other side by doing the opposite. The opposite of a positive x squared is the negative 3x, and a positive 4. At this point, I'm going to try to solve by factoring. And I know the factors of x squared plus x minus 2 is simply going to be x plus 2 and x minus 1. Now, if you wrote these two down as your answer, you just got the problem wrong. Because don't forget that last step. Always look for excluded values. Now remember, to find your excluded value, you take the bottom and you set it equal to 0 and solve. So to find my excluded values, I'm going to say 2x minus 2 is equal to 0 and x minus 1 is equal to 0. That's going to give me x cannot equal positive 1, and if I do the math on this, I also get x cannot equal a positive 1. So what that means is that x equals 1 is an excluded value, and I cannot use this. So my final answer would actually be x is equal to a negative 2 with an excluded value of x cannot equal 1. So when they ask, is there an excluded value? Yes. One of our answers is excluded, and we cannot equal 1, because if I plug that back into the original equation, then it would make the problem undefined. Okay, this problem confuses kids sometimes because of literally how easy it is. This would be considered one of the small problems that we're just going to cross multiply, and that's where people get confused, is they say, I only see one fraction. Well, there's two. Remember, it's always over an invisible 1. Any whole number is over an invisible 1. Then I can still cross multiply. The 2x minus 1 comes up and multiplies times the 3. Again, a point of mistake. People forget to distribute. Make sure you distribute. And the 1 comes up and multiplies times the 6. Now you should be able to solve this very quickly. Remember to always simplify. So if you wrote 9 6, you'd get it wrong because it's 3 halves. Now we need to go back and check for the excluded value. So I'm going to set the bottom equal to 0 and solve. So I have an excluded value of x cannot equal 1/2, and that didn't change my answer, so we're good. Now for problems that are too big to cross multiply, so it's just one below, what we want to do is find the common denominator, meaning we need one of every factor, and this is similar to when we were adding and subtracting the fractions. Then, instead of dealing with these fractions, we're going to get rid of the fractions. So we're going to multiply everything by that least common denominator, because I don't want to work with fractions any more than you do. So the goal is to get rid of the fractions. Then we can solve and check for those excluded values. So if I'm looking at factors, I have an x plus 1 and an x, and then a 2 times x. Notice those are two factors, 2 times x. To find the least common denominator, I'm going to need one of every factor. Now, one way of doing this is to set it up at least common denominator. Set it up vertically. So I'm going to need an x plus 1. Okay, that's one factor. I'm going to need an x, that's another factor. And then I need a 2 times x. Well, notice that's the same x. And then I also need a 2, so 2 times x. And you only need one thing from each column. So I'm going to need an x plus 1, an x, and a 2. The point of having the columns here is if you have repeated factors that you only need one of. So I only need one x, I need one 2, and I need one x plus 1. Now, why am I doing this? I'm doing this to cancel out the denominator, and what I'm going to do literally is multiply each fraction by the 2, the x, and the x plus 1. And what this does is I can go through now and cancel out all the denominators. So on the first one, the x plus 1 will cancel out with the x plus 1. X and x cancel out, 2x and the 2 and the x cancels out. What that does is it gets rid of the fractions. No longer is this a rational expression. Now it's just a regular old problem that requires a little bit of multiplication. And then you multiply whatever's left over. I have a 2 times 2x. 2 times 2x. Plus, I have a 3 times a 2 and an x plus 1. 3 times 2 times x plus 1. And a 5 times the x plus 1. Go through, multiply, distribute, whatever needs to happen. Combine like terms. Remember to solve, we're isolating the variable, so we need to get all the x's on one side and all the numbers on the other. And I come up with an answer of x is equal to negative 1/5. Great, I still need to go through and check for those excluded values. So if I'm looking at the original denominators, I had x plus 1 is equal to 0, I have x is equal to 0, and I have 2x is equal to 0. That means my excluded values are going to be x cannot equal a 0 or a negative 1. So those are my two excluded values. It does not affect my answer at all. So I have an answer of x is equal to negative 1/5. Big problems. Find the least common denominator. Get rid of fractions. Moving on. Here again, I need to get rid of the denominators. I'm going to start by factoring this bottom one here. That is a difference of 2 squares. Gives me x plus 1 and then an x minus 1. Now I'm going to find my least common denominator. The first fraction has an x plus 1 and an x minus 1. The second fraction has an x minus 1, and there is no third fraction. So that means my least common denominator, I'm going to take one factor from each of the columns, x plus 1, x minus 1. That means all the way down, I'm going to multiply an x plus 1 times an x minus 1. Remember, what I do to one side, I do to the other. So I have to do this to the whole thing. Now I can start canceling things out. Change that into factored form. So I have an x plus 1 cancels out the x plus 1, x minus 1, and x minus 1. Here I have another x minus 1, and that's going to cancel out with that x minus 1. Unfortunately, nothing at the end cancels. Now I rewrite and multiply as needed. It gives me an x plus 3 minus 2x times x plus 1 is equal to 1 times x plus 1 x minus 1. Go ahead and multiply, distribute as needed. Don't forget your negative signs. Now I need to move all of the letters to one side since I have a quadratic. And I'm also going to combine my like terms. My negative x and my negative 2x are going to combine, and then after that I can move everything to one side. And what that should give you in the end is 0 is equal to 3x squared plus x minus 4. Now, if you move things the wrong direction and you ended up with a negative 3x squared, negative x, and positive 4, that's okay. Just factor out a negative sign. And this is what I mean. If you move things the wrong way, you would have ended up with negative 3x squared minus x plus 4 equals 0, and we don't want to deal with that negative sign, so you can just take out a GCF of a negative 1. Remember, whatever you do on one side, you do to the other, and what that'll do is it'll change all your signs. X squared plus x minus 4 is equal to, and 0 divided by any number is always 0. So don't stress if you move them the wrong way and you end up with negative x squared. Just factor out a negative 1. All right, now we're going to solve by factoring. If you don't remember how to factor these, I always use the happy face model, meaning draw a happy face. In the happy face takes its own out of you. Since the end is negative but the middle is positive, I know I'm going to end up with one negative and one positive. The end is 4, so that gives me two options. I can use 2 times 2, or I can use 1 times 4. Now, since the middle is a 1, and I also have a 3, I'm probably going to want to subtract 3 and 4 to get 1. And that's just using the common sense. So I'm going to put the 3 and the 4 in the same house, and then I'm going to put the 1x and the 1 the other factors in the other house. So the factors of 3 are 3 times 1, and the factors of 4 are 4 times 1. Now what we do is we check it. 4 times x is 4x. 3x times negative 1 is negative 3x. 4 take away 3 is 1x. Check. The check is to see if that middle number matches your original middle number. And the answer is yes. The middle number matches the original. So I factored it correctly. Now I can take each of these factors and set them equal to 0. And I have two answers. X is equal to negative 4/3 and x is equal to 1. Now we're not done yet because I need to check for excluded values. So we take the bottoms, and remember the first one I factored into x plus 1 and x minus 1. So I'm going to use those factors when checking for the excluded values. And so for my excluded values, x plus 1 equals 0, x minus 1 equals 0, and the other one's another x minus 1, so I don't need to write it twice. It gives me x cannot equal a negative 1 and x cannot equal positive 1. These are my two excluded values. So I have x equals negative 4/3 and x equals 1 does not work. So I would say I came up or I found an excluded value of x cannot equal 1, and that would be my answer. I have x equals negative 4/3 and then an excluded value that I found as an answer of x cannot equal 1. Alright, here's the next one, and I'm going to run through this quickly. What I want you to do is pause it, try it on your own, and then follow along to see if you got it correct. And I'm not going to explain this one, I'm just going to run through it to make sure that you guys understand it. So my final answer for this is x equals negative 2. I also had x is equal to a positive 1, however that was an excluded value. X also cannot equal 0, that would be a restriction. Alright, let's work our way through this one. First thing you want to do on these is factor anything that needs to be factored. So this one has an x plus 4 and an x minus 1 as a factor. Now, if you look across, we're actually pretty lucky. They could have given us anything on the bottom, and they were nice and gave us the same factors. So our least common denominator is going to be pretty easy to figure out. One fraction has an x minus 1. Another fraction has an x plus 4. And then another fraction has another x plus 4 and another x minus 1. That means my least common denominator is simply the x minus 1 and x plus 4. So multiply everything by the x minus 1, x plus 4, and then we can go through and cancel things. X minus 1's cancel, the x plus 4's cancel, and over here everything cancels. Go back and multiply, distribute as needed. Combine like terms. And then solve for x. And when you solve, you get x is equal to positive 1. Now going back and check for excluded values. I have my denominator of x minus 1 and x plus 4, and then another x minus 1 and x plus 4. I only need to solve each once. I get x cannot equal a positive 1. And x cannot equal negative 4. Now notice, my excluded value, x cannot equal positive 1, is the same as my actual answer. That means my answer does not exist. I can't have that. Well, if I have no answers left, what answer do I write down? The answer that you want to write down is no solution. So the proper answer to this one is no solution. My only answer was excluded. If they ask are there any excluded values, yeah, we have x cannot equal 1, that's an excluded value, but my final answer is actually no solution. The last problem here, I want to run through it really quickly. Pause the video, see if you can get it done on your own, and we'll come back together at the end. So if we take a look at this, you should have come out with two answers. You should have gotten x is equal to a negative 16 and x is equal to a 3. When I checked my excluded values, I saw that x cannot equal 0 and x cannot equal negative 24, which didn't affect my answers at all. So we keep both the negative 16 and the 3.